Welcome to Wagered on Tilt, everyone. I am T, and today I do want to go through the next step within the basics of statistics. Now, in this one, I am going to show ways to visualize what we're trying to track down and how the multiplication and addition of things works. So here we're going to be using tree diagrams. Now, tree diagrams are really useful when you don't want to have to worry about missing a variable. So what that means is that when you're thinking through these different probabilities that are dependent or independent, by using a tree diagram, you can map these out and make sure you're accounting for every potential probability. So this is really useful, especially when you're going to start working with Bayesian statistics. So when you're doing this method, you want to take time to think through the probabilities, think through the possible outcomes, and the paths that they can all take. Some of you may see this and think that this looks very similar to a Markov chain. It can be, only a Markov is huge. This is a very basic intro, so please don't worry about that. Again, we're going to go through a couple of different examples, and that's all we're going to cover today because this is really important that you understand how to visualize your data mentally and written down so that you can actually find the correct probabilities. So what we're going to do is we're going to take a look at this tree over here and kind of walk through how it works, why it works, and how you're using this to try and lay out your ideas on possible options. So in here, we're going to say that we have a magic coin or an unfair coin, where heads is 70% of the time and a tails is 30% of the time. Now in here we have different things that can happen on the flip of a coin. So we have heads, and if we get heads on the next flip, we could get heads or tails. And then on the next flip, we would get heads or tails or heads or tails. And that just continues on and on and on. So there's only two options here, really. So what we're trying to look at this, though, is that you can try and figure out what is the probability of getting a certain amount of events to occur. So if we were to take this first example and say, what is the probability of getting 3 heads in 3 tosses? Well, you would follow that path that has the 3 heads. So it would be 0.7 times 0.7 times 0.7. The next thing you can do, though, while looking at a tree like this, is you can try and figure out, okay, well, what is the probability that I'm going to get 2 heads, right? So just 2 or more, that's all you're looking for. So you have this first path, and then you have this second path, then you have this third path, then you have this fourth path, and then that's it, because then these are all tails and you can't catch up to a second heads down there. So if we were to go ahead and look at this, right, we'd just come up here and we'll just put this here real quick. So we're going to say on this first path, we have 0.7 times 0.7 times 0.7, right? So we're going to go ahead and move this one up here. That will give you the probability of taking that path. Well, in this path, you would go 0.7 times 0.7 and then 0.3. That could give you the probability of going to that path. Now let's go ahead and copy and paste that one and move that here, because again, 0.7 times 0.3 times 0.7, same thing, I just don't need to reorganize them there. So let's go ahead and paste this one again, and then we'll bring it here, because here we start out with the tails, oh no, but then we go 0.7, 0.7 to get the 2 heads, right there. And then if we were to look in here, right, if we were to come down to this tails path, we went tails, tails, we're on our third flip now, so it's not possible to get 2 heads. So what you would end up doing is calculating out what do these actually come to. So this first one is going to come to about 34.3%. So let's go ahead and just put that note in here. So we're just going to say 0.343. So that's what that one calculates out to. So this next one, though, this one here, this one is going to be about 14.5. I think it's like 147 is what it came out to. So if we go ahead and paste this down and then paste this down one more time, right? And we're just going to go ahead and move this over so that they're all in line. So now that we have what these are in percentages, what we do is just add these together. So remember, this is an option. So in order to flow through here, we'd multiply these because they are dependent upon one another. But this is one path that is possible. Now there's another path that is possible. So when you're going through these paths, you multiply to come to your value here, but then once you're done, you sum the paths together, and that gives you your full probability. So when using a magic coin that has a 70% chance of going heads, and you want to get at least 2 heads in a row, right? We've figured out all of our paths, and when you sum this, it comes out to be about 78.5, 78.4%. So that is your chance to get 2 heads in 3 tosses when using an unfair coin. So you can try and figure out what are the probabilities of certain paths, right? So you can also do events. So if I want to say what is the probability of getting two heads in a row, well, let's see the paths that can occur. This one and this one, okay? So then this can occur because this is our third head, or we get a tails, so two heads in a row. If we go here, right, we have only one outcome, which is right here, because yeah, we started with one tails, but we went two heads in a row. The other thing that you can do though is also saying, I want to see that the first flip I get is a heads and the next is a tails, and then after that I don't care, right? So if you went here, here, then you would do this path, and then you would do this path, and then you would sum those together. And then that will give you those probabilities. So that's how these trees can be useful, is trying to extrapolate out ideas and flows that you might miss or forget. So let's take a look at this one. We're going to say that we have a bag of balls that have 6 balls total in it, 4 of which are going to be orange and 2 of which are going to be blue. So now what you're going to do is you would map this out. Now the reason this is different is because the probabilities are dependent upon the prior action. Before, flipping a coin has no outcome on the next action. Each flip is an independent event. These are dependent events. Reason being is because if I remove the ball and I do not put it back in the bag, I am taking it and changing the probability of getting another outcome. So as you can see here, if we have 4 balls that are orange and then 2 balls that are blue, depending upon which one I grab is going to change the next set of values. So let's say we have 4 and I want to see what is the probability of getting 2 orange in a row. So first I would have a 4 in 6 chance here, but then it goes to a 3 out of 5 chance here because I took away an orange ball. So the total ball count goes down, and so does the count of how many orange are still available to take. Now, if you're doing, what's called sampling with replacement, you'd put the ball back in and your probability doesn't change, and you're closer now back to the coin flip concept, right? Because you're not changing the outcomes, they're not dependent. Here they are. So if you were looking at this and you were to say, I want to figure out what is the probability that I only get 1 orange ball, you would want to take this times this, and that gives you your outcome. Then you would want to come to the bottom path and say, well, if I drew a blue ball first, and then I drew an orange, right? So that is saying I only got 1 orange ball out of all of the possible pulls, and then that's how you would calculate it. So you got to remember that when you're working with dependent variables, you need to be able to map these out often because you want to make sure you're modifying the probabilities correctly. So again, if I left this as 4 and 6 and 4 and 6 and 2 and 6 and 2 and 6, then we're saying we're taking the ball out, looking at it, and putting it back in the bag. If that's not happening in your scenario, then you do not want to account for that because it's going to change. So let's go ahead and take this out a little bit further. So I'm going to go ahead and copy this one, and I'm going to put it here. And we're just going to drag this up, zoom out a little bit so that we can see the full chart. Okay, and I'm going to say if we took out another orange, we would now have 2 out of 4. So the reason that we're going to have this is because, again, 1 ball, 2 ball. Now we only have 4 left in the bag, and we've taken out 2 already of the orange, so we only have 2. So now we're down to a 50% chance and a 50% chance. So let's go ahead and take this and make a copy of it, and we're going to drop it right here. Now here, we're going to say blue is taken, right? So we have only 1 blue left, and we still have 3 out of 4 to this one. I'm going to spreadsheet, so we try to shrink this second flip, so we push this here. All right, so if we went with blue, we have a 2 out of 6 chance. If we drew another blue, right, so we go 5, orange here, it would be an 8, 3 to 5. And if we went with blue here, right, we took 1, we went with orange, we would have 5. So we took orange, we get 3, 4, and a 1 out of 4. Now if we go ahead and take this one more time and move this down. And again, all I'm doing is updating these, right? So if I went 1 blue, 2 blue, well, this last blue has no possibility, right? Because again, we started out with only 2 blue, so that means that this is all that's left. So it's a 4 out of 4, so it's a 100% chance. So let's just move this one this way. So what we're going to say is, given that we have 2 blue balls, what is the probability that we actually went orange, blue, blue, right? So that is the order in which we pulled. So you're going to be able to do that calculation here. So first, we need to go ahead and calculate what is the probability of getting that path. So we'd take 4/6 times 2/5 times 1/4. So let's go ahead and do that real quick. So if we take the orange, blue, blue path, that is going to give us a 0.066 probability. So let's go ahead and put this in here. So we're just going to copy this and say that this one is actually 0.066. So the next thing that we need to look at, though, is what are the other paths that would allow for this, right? Because we need to say, given that we have 2, what is the probability that this was the exact path we took? So we can look at other ones that had an outcome of 2 blue balls. So we have this one where you can go blue, orange, blue, or you can go blue, blue, orange, and that's it, right? Because once you come here, we already calculated this path. There's no other blue up here, so we don't need to worry about those. So what we need to do is now calculate what is the probability of going here to here to here. So let's go ahead and calculate that. So that path is going to come out to also 0.066. Let's go ahead and put that there, and then we need to calculate this path. And if you didn't guess it already, yes, this one is going to be the same thing over here, because again, we're dealing with these scenarios. Now, if you were dealing with something a little bit different where maybe this path has a 70% chance, and then over here it's a 20% chance, and over here it's a 30% chance, let's just say restaurants and experiences or football yardage or things like that, right? These numbers are not going to be the same, and that will work just fine. But here I want to try and keep it very simplistic so you can understand and see why we're going with these options. So we have this number, and then we have this number and this number. So again, with Bayesian, what we're going to do is we're going to take the path that we're looking for, right? And we're going to divide it by all possible options. So given that we have 2 blue balls, what is the probability we went orange, blue, blue? So to do that, what we're going to do is we're going to take this as our numerator, so the path we want, the probability. Then we're going to go ahead and divide it. So I'm just going to draw a little line here, like that, and I'm going to get rid of that little chevron. So we're going to go ahead and take this number, our numerator. Let me change this, we'll go to purple. So we're going to take the numerator, the path that we want, and we need to divide it by all possible options. So the possible options are going to be itself, the numerator, right? Then we need to add in another one. We need to add in the next path right here, and then we need to add in the next path, right, which is down here. So now we have our equation. We need to take this number divided by this. So if you do this calculation, if we were to say that we ended up with 2 blue balls, what is the probability that we went this path? It is going to come out to a 33% chance. Now again, this should make sense because there's only 3 other possible options, and that's why this fits, right? And again, I'm trying to keep this simplistic so that you can follow along and understand the logic of this. So we can try this with one more option, which I'm going to set up. So as you can see here, we have a couple of different paths. We have A, B, or C. And then from those, you can either pass or fail. So for this scenario, let's pretend that these are 3 different ways of studying for an exam. And then there's the probability of outcomes based upon studying for this method, whether or not you'll pass or fail. And then what are the probabilities that a student is going to take a certain type of method to study. So we have A has a 50% chance of studying that method, B at 15, and C at 35. If they take A's method, they have a 70% chance of passing, 30% fail. B, it is a 60% pass, 40% fail. C means that they'll pass 80% of the time and 20% will fail. So again, these are the probabilities based upon choosing a certain study method. So now we want to see, given a certain result, what is the probability that somebody chose a certain path? So if I were to tell you that somebody has passed their exam, what is the probability that they actually went with path A? So here we can see again, we have the 50% and 70%, right? So what is the probability, knowing that they passed, that they went down this route rather than B or C? So to figure this out, we need to figure out our numerator first for what our equation is going to be, which is going to be 0.5 times 0.7, right? Because we went down this path and then this path. So we need to multiply those 2 together. So what that's going to give us is 0.35. So we're going to go ahead and just put that in there. So we have the 0.35, right? Now we need to go ahead and divide. So let me just copy one of these lines here. Just going to move that up here, and it's going to be the dividing line. There we go. Okay, so we have this path right here divided by, now we need to also pull in the probabilities of the other options. So first we need to use the one that we used above, because again, it's all potential paths, right? So we're going to take the path that we want to check against all possible paths that lead to a pass. So A to pass, B to pass, C to pass. If you follow along, right, we don't include the fails because those aren't in this equation right now. We're only looking at people that have passed. So we have then, for this path here, we have 9%. So I'm going to go ahead and copy this, put this in here, and we're just going to go ahead and say plus 9%. And then we're going to have another one right here, and then this one is going to be 28%. So we have 35% times 8% gives us 28%. Then we have 15% times 60% gives us 9%. So let's go ahead and take a look at this again from top to bottom. So we have, going down this path, A times pass is going to be 35%. B times pass is 9%. C times pass is going to be 28%. So we take the one we're trying to evaluate and divide it by all potential paths. So the way you would say this is, given that a student has passed their exam, what is the probability that they took study method A? So this is the formula. And once we complete this, this actually comes out to about a 46.5% chance. So we'd say that there's a 46.5% probability that they actually took path A. And we can then do that also with B. So since we know what these are, right, we know that this is 0.9. So I would just then swap this out and say, okay, well, let's then go by 0.9, because I already did the math that 15 by 0.6 is going to go ahead and give me 0.09. So now I'm just going to swap it out. So this equation is now going to say this is the probability that they took this path B. So that one's going to come out to about a 12.5% chance. So then we're going to do the last one here, which is going to be the C. So we just go ahead and swap this out. And again, we've already calculated out this path. So we could just take this number and pop it in as our numerator. So from this, we'd get about a 38.5% probability. So once you figure these paths out, you can start playing around and popping these numbers in and moving them around to figure out the probability of different events occurring. Now, if you want to check for the probability of somebody failing and say, given that a student failed, what is the probability that they took path A or B or C? You'd do very similar. You would take this path A, but then you would multiply it by the fail path. So 0.5 times 0.3. For B, it would be 0.15 times 0.4. And for C, it would be 0.35 times 0.2. You would choose which one you're trying to evaluate for. So given that they failed, I want to see if they took path B. So I'd take whatever this value is, 0.15 times 0.4, and I'd put that as a numerator, put it down here in the denominator, and then add the other two paths to it. So that's all we have today for the new probability course. This is super simplistic. Again, we're just diagramming out and using a tree to map out all the potential paths that you can take to find the correct probability. Now again, this works with Bayesian, this works with non-Bayesian methods. This is a great tool to use to ensure you're tracking all of the potential outcomes that you need to evaluate for. If you liked the video and found it useful, please like and subscribe. That way you're notified as soon as the next video is available. If you thought this was useful, please let other people know about it. That way they can learn and develop their own skill set. If you do have any questions, comments, or concerns, please feel free to drop them in the comments down below. I will respond to you. And then if you need any other additional help or have questions, you can reach me in the unabated Discord as the T, or you can reach me on X as Wagered on Tilt. So that is it from me today. Until next time, happy wagering.